Alright guys, how you guys doing? It's Tuesday, March 24th. Today we're going to go through some dividing of polynomials. Alright, I am limiting all of my videos to under 30 minutes. Alright, so you will never have any part 1, part 2 videos again. I'm going to keep them under 30 minutes for you. So today we're going to just do half of this, right, and then tomorrow we'll focus on the other half. And you can turn all of the homework in at one time in a few days from now. So you can start it tonight if you would like. But I'll go over that at the end of the video and in an email as well. All right. If you're having trouble posting things onto Google Classrooms, again, please try it a couple times. If it's really not working, I understand that that's frustrating. So please just send me an email with the assignment, and I will make sure I check those. Okay. If I don't get back to you right away, I'm getting a lot of emails every day. So it's very difficult to do two things at once. All right. So if I don't get back to you right away, it's okay. Wait until the grades are in. If you've sent it to me and I put it in accidentally as a 0, I can go back and make that change for you. We have plenty of time to do that. All right. So just keep an eye on your grades as they go in, and if I made a mistake, let me know. Okay. All right. Here we go. So first, we're going to review dividing a polynomial by a monomial. Again, this is a polynomial up here. All right. We have 3 terms. It's a trinomial. All right. You can call polynomials or trinomials polynomials, or anything with more than one term is technically a polynomial, but we have binomials, trinomials, and then 4 and above, we just call them polynomials. All right. So let's divide this. All right. Remember, we need to distribute this. So I'm just going to kind of do this shorthand. All right. Just do this quickly. So 6 divided by 3 gives us 2. X to the 4th divided by x to the 2nd. Right, we subtract the exponent, so that gives us x squared. All right, negative 15 divided by 3 gives us negative 5. X to the 3rd divided by x squared, just subtract them. All right, the bigger one again is on the top, so we have x left over. All right, and then plus 3x squared divided by 3x squared. All right, well, these are the same, right? And a lot of guys I saw in the quiz, you're just letting these, this is the quiz from a while back. You're just saying, oh, well, these just cancel out. Well, they don't necessarily cancel out. I don't want you to think of it that way, okay? 3x squared divided by 3x squared, that's 1. All right, so don't forget that these don't cancel out. All right, it's 1, okay? I understand we've probably said the words cancel out before in the past when it comes to dividing and getting 1, but this is being added at the end. It's not being multiplied, right? The reason we get rid of it, and we've gotten rid of it in the past, is because when we multiply by 1, it does somewhat disappear, right? But when it's being added, we need to keep that place. So if there's 3 terms on the top at the start, there should be 3 terms on the top at the end, okay? So that's the first one. It's the final answer. There's nothing else we can do. It's just dividing, right? And then this one, we're dividing here, and we're dividing here. All right, 21 divided by 7 gives us 3. A to the 5th divided by a to the 1st. That's an a to the 1st there. It's hard to see. Yeah. All right, let me just fix that. All right, so a to the 5th divided by a to the 1st here. All right, that will give us a to the 4th. B to the 3rd divided by b to the 1st. Right, looking down below, that gives us b squared. On to the next term, negative 14 divided by 7 gives us negative 2. All right, so minus 2. All right, a to the 3rd divided by a to the 1st, a squared, b squared divided by b is b. All right, 63 divided by 7 gives us 9. Positive 9, so we make that plus. A squared divided by a gives us just a, and then b. And this is where that would disappear, right? These do technically, you can say that they cancel out. Again, they don't cancel out, but b divided by b is 1. 1 times 9a, which is left over, is just 9a, right? So that's when that would be the big difference there, right? So that's good that those 2 problems showed us those times. All right, well, now we're doing something a little bit different here. All right, we're dividing by a binomial. All right, we've done this before, right? That's why it says review there. We've done dividing by a monomial. We have not yet done dividing by a binomial, right? So there's a few ways to do this, all right? And I showed you the first way a couple weeks ago. I said, here's what we're going to be getting to eventually. This is an important concept to understand, all right? But there's only really 2 problems that use the method I was talking about. we're going to have to do something a little bit more difficult in long division, and we're just going to focus on long division today. But this right here, right, this is all new. All right, this is the factoring method here. I got a new stylus, so it's better. All right, this is going to be the factoring method. All right, this is definitely the best method to use, but the problem is we can't always use that method because sometimes the trinomial is prime and we can't factor it. All right, so we have to do something else. All right, well in this case, they can be factored. All right, the trinomial at the top, the numerator, can be factored. All right, so what are two factors of 10 that multiply together what are two factors that multiply together to get 10, but add up to get -7? All right, well, again, they're both going to have to be negative, right? A negative times negative gives us a positive. When we add two negatives together, we get a negative. So -5 times -2. When we add them, we get -7. Boom, that's it. So we factored the top, just doing our normal trinomial factoring. W minus 5 over times W minus 2 over W minus 5. Getting ahead of myself. All right, now, I want you to think about this for a second. All right, this is kind of a side note. I'll do it in a different color over here. All right, you don't need to write this down, but I want you to think about this, okay? If I said to simplify 6 over 2, right, how would you do that, right? Well, you would say, oh, that's 3, right? It's 3, or 3 over 1, which is 3, right? Well, how did you do that? Well, in your head, you did exactly what we just did right over here, right? But we can't do this side over here in our head, right? We need to factor it out using math and using the skills that we've learned, right? Here, this has kind of just come natural at this point, right, where we can just simplify that quickly. But what you were really doing is you were finding the factors of 6, right, and trying to find GCFs between 2 and 6 here, right? So if we broke it down, right, you would say 2 times 3 is 6, right? So we are writing that on the top instead over 2. And then in a sense, what's happening is we're saying, oh, these factors are the same. We can basically cancel those out. We can divide them. 2 divided by 2 is 1, right? So these do in effect cancel out, right? And we're left with 3 over 1 or 3, all right? So this is simplifying a fraction, right, by using factoring. What we're doing now is simplifying a fraction by using factoring, right? So I'm going to erase that. Hopefully that made some sense. If not, you'll see right here. Do we have any factors that are the same over here on the left side? Okay, we do. All right, we have w to the -5th and w to the -5th right here. Now, because they are the same, right, when we divide them, they both become 1, right? And because we have something left over at the top and we don't need 1 on the denominator, all we're left with is w minus 2 over 1, which is just w minus 2, and that is our answer right there. Okay, so again, what we're doing is we're factoring out the numerator, seeing if there are any common factors between the numerator and the denominator. If they're the same, we can cancel them out, and whatever's left over is our final answer there. All right, so let's do this one. We'll set this up. First of all, let's find factors of negative. Oh, this is one of the special factoring. All right, so we need to special factor this. All right, so 4 times -2, right? That's going to give us a -8, right? So, yeah, sometimes we have to do this, right? They're going to continue. As I said, anything that we learn is a building block, all right? So don't ever just try to skim through something. Look, we're using this again, right? This is the special trinomial factoring when a is greater than 1, right? So that's what we're left with. What are the two factors of -8 that add up to get -7? We got -8 times 1, right? So we are left with h minus 8, because when we add those, we get -7, which is b, and h plus 1. All right, now we bring a back in. All right, I'll use that here. We're bringing this number back in and dividing it to the backs of these, right? Simplifying it, if there's any denominator left there, we move it to the front of that binomial. So these simplify here to get us h minus 2, all right? And let me actually write this a little bit higher because this fits really well with our problem. H minus 2, all right? And this is simplified, so we're going to move that just to the front of that binomial and get 4h plus 1. Now, that was the numerator of our division problem up here at the top. So we need to put that all over h minus 2. And do we have any common factors? We sure do, right there and right there. So we are left with 4h plus 1 as our final answer. All right, so that's using factoring. So, yep, we do still need to remember how to do the special factoring, right, which was just the week before we left school. All right, so it should be still fresh in your head. We're going to be working with it all the time. So get to that. Make sure you hold that information in your head and keep that going. Okay. Now we're going to use long division. All right. Today we're not going to be doing any of this. We're not doing method 2. All right. We're not doing that today. We'll do that next class. All right. I believe section 3. That's you guys tomorrow. I do believe. All right. Tomorrow being a flex day. All right. So we are going to use long division. All right. Because we can't find factors of negative 43, right, that add up to give us 3. So that means that this trinomial right here is prime, right? It's a prime trinomial, means it can't be factored, right? Can't be factored, all right? So if it can't be factored, what do? We have to use long division, all right? We have to use long division. Now, I'm not going to go through steps necessarily, okay? But I want you to pay attention. Again, if you repeatedly do this, you'll understand it, all right? At first glance, this isn't always easy to understand. But I think if you just pay attention and continue to practice these, you guys will do a great job with it, all right? So I'm not going to cross this side out here. I'm not going to cross them out, but I might do some work on that side as well. All right, so here we go. All right. So we have long division, right? Now, this is the numerator right here, right? And this is the denominator, okay? What you need to think about is the numerator goes inside of the division sign. I'll show you what I mean here, okay? So we're going to make a division sign here, just like old school, right? And the first term, right, or the first thing that's being divided, right, is going to go inside, right, inside. So let's go ahead and put that there, all right? We have x squared, and we don't need to put the parentheses, x squared plus 3x, this stylus is so much better, minus 43, and then x plus 8 on the outside, all right? So I'm going to write this here, first term. All right, we're always going to be looking at the first term, so I think that's what's important to understand right now. All right, so the first term is, of course, x. All right, so what we're going to do is we are going to divide x squared and x. All right, so the first term here, divide that by x. All right, so when we do that, what do we end up getting? X squared divided by x. Well, we end up getting x. All right, so what we're going to do is we're going to put that x over top of where we see the x. All right, so there's an x there, so we're just going to line them up, okay? And we're going to put that up at the top. All right, now I'm going to erase this. All right, we just divided by the first term. That was it. First term to the first term. Now we're going to end up multiplying that back to each of these, right, and putting them under the like terms that we see above, okay? So line them up with the like terms. You don't need to write that, okay? I just want you to see that and understand it, right? So line them up with the like terms. So here we go. All right, x times x gives us x squared. Now let me do that in a different color so you can see it. Gives us x squared. All right, and then 8 times x right here, the second one, right? 8 times x is plus 8x, all right? And we're going to end up putting that in parentheses and subtracting, all right? Now, again, just like normal division, right? If you were doing long division, you would subtract, right? So we're doing the same thing here. So this is really technically being distributed to each of these, all right? I'll show you the way I think about it. X squared minus x squared, right, is going to give us 0. We don't need to write anything there, okay? And then 3x minus 8x right there, okay? 3x minus 8x will give us a negative 5x, all right? Negative 5x. Now, we're going to take that negative 5x, right, and that's going to be divided again by this first term. So I'm going to bring this, once we're left with that, right, we divide it by the first term. Negative 5x divided by x gives us negative 5, right? I'm not going to write that there, okay? So we just need to, again, once we subtracted, we get our new term, all right? And then take the first term of the binomial on the outside, which is x, and then divide that by our new term, right? So we've divided that now twice, right? That goes on the top, and of course, we're going to do the exact same thing here. The precision, the accuracy of that was just amazing. Amazing. All right. So we're going to take this minus 5 now, right, to negative 5, remember that, and we're going to divide it amongst all of this. All right, when we do that, we're going to write that underneath, under the like terms. All right, oops, sorry, that minus 5x should still be there. And we didn't bring down the negative 43, my bad. I'll show you that again. But once we've figured that first term out, we can bring that minus 43 down, because that's what we would do with regular division. All right. So now we're back to multiplying this negative 5 here. All right. We have to multiply that negative 5 to both terms in the binomial. All right. So negative 5 times x gives us negative 5x. All right. And then negative 5 times 8 gives us negative 40. And again, this is going to be in parentheses and being subtracted. So remember what we can do here, right? We can do keep, change, change here, right? This can just now all be added, right? Changing the signs, okay? That's what you can do when you distribute that, all right? So I'm going to go ahead and change the signs. This is now plus, all right? When you distribute that minus sign, that's what, in effect, happens, all right? So this becomes 0 here, right? And then negative 43 plus 40 gives us negative 3, and that is our remainder, minus 3. All right, so what do we need to do with that remainder? Right, we need to take this x plus 8, right, and put that as the denominator, and we are left with an answer of x minus 5 minus 3 over x plus 8. And that is our final answer there. All right, so our remainder needs to be over the binomial. All right, which is the divisor. All right, let's go to the next one. Again, I think repetition will really help you here. All right, so I'm going to scroll down. Give me one moment. We're at 18 minutes right now in the video. All right, so again, this will I'll make sure this is done within 30 minutes. So we have 12 minutes left. All right. So here we go. We're going to set this up. All right. Again, what's going inside is going to be the trinomial going inside. All right. So I'm going to actually use this space over here as well. All right, so hopefully you're thinking first term. All right, so we have n minus 7. Well, we're just looking at the first term. All right, so divide the first term to the first term here. All right, we end up getting 2n. All right, so that's the first number we're writing at the top. All right, whatever it divided into. All right, so we are dividing it by n. We end up getting 2n, so we write it over top of the like term. All right. And then now we are going to multiply this 2n to both the front and back of the binomial. 2n times n gives us 2n squared, and then 2n times negative 7 gives us negative 14n. All right, parentheses, and this needs to be subtracted. All right, so 2n squared minus 2n squared, those will end up canceling out. But if you look at this one here, right, we have looks like negative 16n minus 14n, but remember it's negative 16n minus negative 14n, right, which again we can think of as both as plus here, right, and if we did that, this would just be a negative, so it would still cancel out. All right, so negative 16n plus 14n gives us negative 2n. And here is where we could bring down the plus 19. All right, so let's bring that down. All right, so plus 19. Okay, again, dividing the first term here. All right, dividing the first term. N right here. All right, when we do that, we end up getting negative 2, so minus 2 right there. Okay. Now we just need to find our remainder, so we need to multiply that out. Oops, minus 2. Sorry. Okay, so now we need to take that and distribute that to the n and the negative 7. All right, so when we do that, let's go ahead and multiply it. Negative 2 times n gives us negative 2n. Negative 2 times 7 gives us plus 14. And we are subtracting. So again, these first two, right, if we were to do this, this would become negative 2 plus 2n, which is 0, so those cancel out. All right. Just ignore the problem there, I'll erase it. All right. So these cancel out here, and then 19 minus 14 gives us 5. So that's our remainder. And that needs to go, we need to take this down here and put it over underneath n minus 7. All right, that's our remainder. So that's a positive 5 over n minus 7, right? So what we'll end up having as our final answer is 2n minus 2 plus remainder of 5, which needs to be over top of the binomial n minus 7, and that is our final answer. All done. Let's simplify as we can get it. I wish they would have left me more space low. I like the way the other problem was set up. All right. But if you need to see it, it's a video, so you can go back and check it out. All right. So here we go. I'm going to write the problem actually up here. All right. So y minus 2 on the outside. On the inside, we got to put the trinomial. Oh, look at that. We got multiple terms here. All right. So definitely probably didn't leave a space. This will be the last problem we do. All right. Y to the third plus 5y squared minus 7y plus 2. All right. You all right? I think my cat's sneezing over there. All right. So first thing we need to do is divide. All right. So we're going to divide y to the third. Over that, we end up getting y to the third divided by y to the first here. Right. It's y to the first. When we get that, we get y squared. So we're going to put a y squared up here. Okay. Then we need to multiply that out, all right, to each of these. All right, so I'm not going to write all of that right now. You, again, just try to see that we're multiplying y squared times y to get y to the third. All right, and then y squared times negative 2 gives us minus 2y squared. All right, we are subtracting this out. All right, when we do that, we end up getting y. These cancel out here. All right, and then 5y squared minus negative. Again, we can think of these as plus, so we're adding them, and we end up getting 7y squared when we do this. Okay, 7y squared. Bring down the minus 7y. Okay? Now, dividing again this first term, all right? 7y squared divided by our first term of the binomial, which is y, right? We end up getting 7y. Okay? We get a positive 7y. So plus 7y goes up at the top. All right? Plus 7y goes up at the top. All right? Now we need to go ahead and multiply that to each term of the binomial. All right? So 7y times y gives us 7y squared. And then 7y times negative 2 gives us negative 14y. Okay. Now we're going to go ahead and subtract these. The first terms will, and they should always cancel out. It's kind of the point, right? So those cancel out, right? And then we have negative 7y plus 14y. And we change those, and we end up getting a positive 7y. Plus 2, bringing down this 2 all the way up here. All right. We're almost done. All right, let's divide this again. We get the first term here, y, right? We have to divide that to the first term down here, and we're just left with a plus 7, a positive 7. So put that up at the top. Okay, now we're finding our remainder. All right. Plus 7's up there. Erase this. All right. Now we need to multiply that 7 to each, and we end up getting parentheses 7y, right? And then 7 times negative 2 gives us minus 14. We are subtracting. The first terms, as I said, they will cancel out, and then these can become addition, minus, minus. All right, keep change. 2 plus 14 gives us a remainder of 16. So our final answer here, all right, we just put that over top of our binomial. So over y minus 2. All right, so let's write out the final answer for this problem. Y squared plus 7y plus 7 plus 16 over y minus 2. Sheesh. All right, so that's doing long division. All right, I will post this video. I will post another video if you guys are having some issues with it. There's one I found online on YouTube that's great. The guy does basically the same thing, but it just goes a little bit more in depth. It also shows some easier problems as well. I think we went right into atomic here with this worksheet, but I'll send that over to you as well. If you have any questions, please let me know. We're going to be doing some Zoom things here, Zoom meetings. Mr. Kohler sent out an email or actually Mr. Streckfus did through Mr. Kohler, talking about potentially having office hours for the teachers through Zoom meetings, where you guys could connect to the meeting itself and ask me questions, whether that be about class. We can talk about how the online learning is going, things that could be different, things that could be better, and get suggestions there as well. So keep up the good work, guys. And as far as the homework goes, I will post that onto Google Classrooms, but it will not be due until we finish this lesson up. So the next class will finish this lesson up, and then I will assign the second half of the homework, which both those will be due at the same time. All right? Have a good one.